from before, I've written down some measurements here, some things we already know. What we were given was that this length was 6 centimeters and that this length was 4. Because it's a true rectangle. Now the same thing goes for here, 4.5 centimeters. This is going to be 4.5 centimeters as well. Okay. Now again, what you have to ask yourself is, how do I get from here to here? This times what will get me right here? Well, remember, from algebra unit, you can make yourself an equation, and this will work every time. 6 times something, 6 times x, equals 4.5. And what we'll have to do is we want to get rid of the 6. And when we find out what x is, all we have to do is take that number and multiply it by this, and we'll figure out what this side is. Then we can figure out what the perimeter is. All right, if we have all 4 sides added up, the perimeter, for example, of this rectangle right here is 6 plus 6 plus 4 plus 4, which is 20. Well, we're trying to find out the perimeter of this one. We already know 2 of the sides. We've got to find out this side and this side right here. So again, we're going to divide by 6 on both sides, leaving x by itself equaling 4.5 over 6. Well, of course, something goes in the house, and that's top dog goes in the house. Divided by 6. Bring our decimal point right there. Okay, and let's go ahead and put ourselves a few zeros here. 6 will go into 45 7 times without going over, leaving us a remainder, with a 42 down here, 3. Bring down our zeros. 6 into 30 is 5. 5 times 6 is 30. For a remainder of 0. So x equals 0.75, okay, or 3/4. Then all we have to do is take that number and multiply it by 4 to figure out what that side right there is. Okay, so we would say 4 times 0.75, and the answer to that is 3 centimeters. So now on our second triangle, we're going to have 4.5, 4.5, 3, and if this is 3 over here, this is 3 also. Okay, so 4.5, 4.5, 3, and 3. That equals 15. Therefore, the answer is a perimeter of 15 centimeters. Now that may be one you have to watch over and over again, but that's okay. This one is a multi-step problem. Dante drew a parallelogram. So let's just go ahead and do what he did. Parallelogram, that means that both sets of sides are parallel. This one's parallel, these two are parallel, and these two are parallel. With a base length of 35 centimeters and a height of 10 centimeters, which also means that this is 35 and that this is 10 also. He then drew a second similar parallelogram. Not an exactly congruent one, but a similar one. So he drew one maybe a little bit smaller, a little bit bigger. Using a scale factor of 1 over 5. That's the key number there, 1 over 5. What is the area of the second parallelogram he drew? The formula for area of a parallelogram is area equals your base times the height. Okay? Where B is the base and H is the height. So what we need to do for this other one over here, we need to say that it's going to be basically 1/5 the size of this one. So we need to multiply these sides by 1/5. We only really have to do 2 of them. This one and this one right here. Because you, by virtue, you know, so you can find this one, and then you'll find automatically that one and that one there. Okay, so we just need to multiply 35 times 1 over 5. Well, we can do that by saying 35 over 1 times 1 over 5, which is 35 over 5, which is 7. All right, so we've got 7 on top, and we also have 7 on bottom because they're the same. Now all we need to do is multiply 10 for this side right here times 1 over 5 which is the same thing as 10 over 1 times 1 over 5, equals 10 over 5, and that equals 2. So we have a 2 there and a 2 there. 7 plus 7 is 14, plus 2 is 16, plus 2 is 18. So we have a perimeter of 18, but keep in mind, they're asking us for the area. All right, in order to get the area, you have to multiply the base times the height, okay, which is 7 times 2, which is 14 centimeters. Now this one you have to pay close attention to as well. Yolanda designed the rectangular back-to-school night banner shown below. The art club plans to create a full-size banner, so she created this one. But the art club wants to create one like this. The art club needs to provide the printer with the measurements of the banner. What is the value of Z? All right, so if we know that we're going to make one similar to this. In other words, the angles are going to be the same, but the lengths aren't. How do we get from 1 to 4? Didn't we multiply by 4 there? Didn't we multiply by 4? So we would multiply anything else by 4 to figure out Z. So we need to multiply 1 feet 8 inches by Z. Well, we can't just say 1 feet 8 inches times Z. We have to say 1 feet and 8 inches is the same thing as 8 over 12, because there are 12 inches in a foot. So we need to know how many feet we've got. This is the same thing as when we reduce this to 2 over 3. Then we would multiply that 1 2/3 times 4. Okay. Well, as you know, when we multiply fractions, we have to change this to an improper fraction. It says 3 times 1 is 3, plus 2 is 5 over 3 times 4, which is 4 over 1. Well, this is 20. This is 3. Okay. Now remember, top dog goes in the house. 20 and 3 there. 3 will go into 26 times without going over. Six times 3 is 18. Remainder of 2. So our answer is 6 2/3 foot. Or you can convert that to inches if you'd like to, kind of like what we had here. 6 feet and 8 inches. Now be careful with this one, because this one has been flipped over. Triangle DFG and HJK. Which statement about these triangles is true? Now look, let's just go ahead and take a look. This one's 12 meters, the base is 12 meters, and this base is 6 meters. So we have a scale factor or ratio of 1/2. In other words, you multiplied everything over here times 1/2 to get everything over here. And that would apply right here. 20 meters, therefore 20 times 1/2 is 10. 16 times 1/2 is 8. Okay, now the question is not asking you to do this, but I can tell you just by looking at these, it's probably going to ask you something like that, so it wouldn't hurt to go ahead and put those side measurements on. The length of HK is 8 centimeters. Well, that's not true. And remember, we're looking for which statement about these triangles is true, so be careful. The side lengths are related by a scale factor of 2/3. Well, no, we talked about this already. This is 1/2, so no, that's not right. The perimeter, in other words, the addition of all sides of HJ DJK is twice the perimeter of DFG. Well, that's not true either, because this one's obviously going to have a smaller perimeter than this one. It's going to be about the same size. It's going to be about half. Okay? So that's obviously not the case. The area of HJK is 1/4 the area of DF and G. Well, in this case, you would multiply 1/2 times the base times the height. In this case, this would be the correct answer, because 12 times 16 the area of this triangle is 24, and the area of this triangle is 96. All right, and that is 1/4 the area there. So the answer is D. Which statement is not true about similar figures? Which statement about similar figures is not true? The corresponding angles of similar figures are always congruent. Yes, that is true, so therefore that is not a choice, because we're looking for not. The corresponding sides of similar figures have proportional lengths. The corresponding sides of similar figures have proportional lengths. That is also true, so we're going to eliminate that choice. C, the ratio of perimeters of similar figures is equal to the ratio of their corresponding sides. In other words, if this perimeter is, 28, 48, and we know the scale factor is 1/2, then by definition, this perimeter has to be 24. And I can add that up by just looking. 6 plus 8 is 14, plus 10 is 24. So that is true. We marked that out. The ratio of areas of similar figures is equal to the ratio of their corresponding sides. Now, as we said before, just because you have a scale factor of 1/2, does not mean that your area is going to be 1/2. It's going to be 1/2 of this, which is 1/4. So this is the correct choice. More to come.